Buenas tardes, queridos amigos.
Good evening, dear friends. Welcome to the final stretch of the Faith and Science Fundamentals webinar series. Today we begin our last module, Geology and Paleontology, in which we will investigate what rocks and fossils tell us about origins. Flood geology. If I were to ask you, what is the clearest geological evidence that there was a universal flood that covered the entire Earth? Some of you would probably answer with this: the presence of marine animal fossils found in the tallest mountains. If we find remains of marine animals high in the mountains, that proves that the flood, just like the Bible says, covered the entire Earth and the waters carried the animals there. This argument, which might seem incontrovertible, was widely used by the creationists of the 19th century and the first half of the 20th century. But I regret to tell you that, according to their current knowledge, it is not a good argument, and it's not even evidence that the waters of the flood could have covered the mountains. Also, the two terms that make up the title of our topic today, flood and geology, are much more complex than it might seem at first glance. We're going to try to explain both terms and the relationship between them in a brief and simple way, but I assure you that it is a big challenge. So I'm going to recommend that you watch some videos as a complementary aid to this talk that will provide you with more details that we will not have time to cover today, and it will help you in understanding this exciting topic better. Geology is the science that studies the Earth, and it does so at different levels, from the most global level, the structure of the planet and how it works, to something much smaller, like the composition of minerals and rocks that make up the Earth's crust. In Spain, to study geology, you have to complete a 4-year university degree. So, in this short time, we will not be able to do more than a very brief introduction to some of the geological concepts that interest us for the subject of this series. And they are mainly two: the structure of the Earth and the types of rocks. If we could cut the Earth in half, we would see that it is organized in concentric layers of different materials. The outer layer is very thin and is called the crust. The second layer is called the mantle, and the innermost layer is called the core. The layers of the Earth are not static but move. The core is made up of metals such as iron, and in part of the core, the material is molten and moves continuously in circular currents. And that moving iron is what causes the Earth's magnetic field. At the top of the mantle, there's a layer called the asthenosphere, which is in a fluid state, which is neither liquid nor solid, but it allows it to move slowly like thick gelatin. Above the asthenosphere, there's a layer of hard, rigid rock made up of the crust and a piece of mantle called the lithosphere, which means stone sphere. The lithosphere is not a continuous layer, but is broken into pieces of different sizes fitted together like a puzzle. When the asthenosphere moves, it drags the lithosphere that is above it. I'm going to show you in an animation here. There it was. And as the different areas of the asthenosphere move in different directions, there are times that pieces of lithosphere rub against each other, collide, or separate, leaving a gap. Those chunks of lithosphere are what geologists call tectonic plates. And the study of them is called plate tectonics, which I'm sure you've heard of. When we talk about plate tectonics, we mean huge blocks of the Earth's surface that sometimes include entire oceans or continents. So as you can imagine, if one continent collides with another, it would have very great geological consequences. Plate tectonics is a relatively recent theory. Before the 1960s, the continents were considered to be fixed and immovable. But since the scientific community accepted that the surface of the planet is quite dynamic, many of the geological structures that we observe are explained as giant scars of the Earth caused by the interactions between the tectonic plates. For example, Iceland is located on the border between two huge plates that are separating, and material from the mantle is coming up to the surface through the gap between them, forming a giant volcano that runs through the center of the Atlantic Ocean. So Iceland is part of the volcano that has grown out of the water and stands above sea level. The San Andreas Fault in California marks the border between two plates that move in different directions and whose friction causes earthquakes in the area. And the Himalayas are the result of the clash between India and Asia. We could say that they're the wrinkles caused by the collision between the two land masses. I'm going to try and show you also in another animation. Let's see here. There we go. From this point of view, finding marine fossils high in the Himalayas does not imply that Everest was covered by the floodwaters in the past. The current explanation on which both evolutionary and creationist geologists agree is that when India collided with South Asia, materials from the seabed that separated the two continents were pushed up and lifted during the collision and incorporated into the mountains that were forming. As I said before, this topic is complicated. If you want a more developed explanation, I recommend this talk by Dr. Rani Nalin, geologist and director of the Geoscience Research Institute. Why should we care about rocks? In this talk, Rani also explains what we're going to see next in more detail, which are the types of rocks. The rocks on the Earth's surface, including those on the seabed, can be divided into three large groups. Sedimentary rocks, which are made up of fragments of other rocks. Igneous rocks, made up of very hot molten rocks, such as lava that is cooled and then solidified. And metamorphic rocks are formed from other rocks that have been subjected to an increase in pressure and temperature that has altered their characteristics, but has done so without actually melting them. The same thing happens with rocks as with continents. They may seem very stable to us, they don't change, but in reality, the rocks of the Earth are also dynamic. A rock can break, fall apart, or melt, and become part of a different rock. What happens is that these processes are normally very slow, and we hardly notice them. But in certain circumstances, such as in a volcanic eruption, a rock can be formed, destroyed, or altered very quickly. The rocks that we are most interested in are sedimentary rocks. We've said that they are made up of fragments of other rocks. But where do these fragments come from? Well, the rocks on the Earth's surface are subjected to atmospheric agents such as rain, snow, wind, or changes in temperature, which erode them. That means that they are breaking into small pieces. And these small pieces can be transported by the wind or by water to another area. And when the wind or the river slows down, they are deposited and accumulate, usually at the bottom of lakes or seas. The weight of several layers of sediment, one on top of another, causes the water to be expelled and the rock fragments to compact. Then, chemical reactions that can take place cause some substances to dissolve in the water and then precipitate between the sediments, sticking them together as if it were cement. These compaction and cementing processes end up turning loose sediments into sedimentary rock. Depending on the type of fragments that form them, sedimentary rocks receive different names. Those that are made up of grains of sand are called sandstones. Those that are made up of rounded pebbles are called conglomerates. And those that are formed by stones with angular edges are called breccia. There are many other types of sedimentary rocks, but the important thing is that the components of sedimentary rocks give us information about how and where they were formed. For example, wind has less force than water, so wind-borne sediments are smaller and lighter than water-borne sediments. The conglomerates that have rounded fragments tell us that these fragments were transported for quite some time, and the pebbles became rounded in the process. Depending on the type of cement, we can know if the rock was formed in fresh water or in salt water, and if it occurred in deep or shallow waters. Another super important thing about sedimentary rocks is that they are the rocks that contain fossils. More rarely, we can find fossils in some igneous or metamorphic rocks, but the vast majority are found in sedimentary rocks. Next week, we'll talk about fossils, but now at least you know where they can be found. But how can we distinguish a sedimentary rock? Well, one of the characteristics that helps us identify them is the presence of layers. When you see a lot of layers of different colors on a mountain or on a road cutout, those are sedimentary rocks. Remember this because we will use it in just a little bit. And that's it for our very brief introduction on geology. Now let's talk about the flood. As it happens many times, the information provided by the Bible is quite concise. All the outlets of the vast body of water beneath the earth burst open. All the floodgates of the sky were opened, and rain fell on the earth for 40 days and nights. And from these and a few more phrases, everyone imagines the biblical flood in a different way. According to the pictures in children's Bible stories, we would say that the flood was simply a long period of rain. We're used to seeing an ark rocking in the waves and the animals leaning out of the windows, smiling, or at most a little bored, wanting it to stop raining so that they could go out and play. And without realizing it, many adults have the similar idea of the biblical flood. A very big storm, and perhaps, because of the fountains of the abyss, jets of water coming from deep inside the earth or from the bottom of the sea in the form of geysers. But in short, it is thought to have been 40 days of torrential rain that caused the oceans to rise so much to cover all the landmass and kill all the people and animals outside the ark. And a few months later, the opposite process, a progressive lowering of the level of water that uncovered a desolate land. But according to creationists, geologists, that's not what happened. Although we don't have all the answers, the data from geology and paleontology suggests that what happened during the biblical flood was much more extreme and terrifying. First, most of the rocks found today on the continents are sedimentary rocks that were deposited in marine environments, while the rocks on the seabed are recent volcanic rocks. This means that during the flood, the surface of the Earth changed in configuration completely. Where there were once seas, there are now continents. The water currents were so brutal that they eroded all the emerged land and dragged the materials to the bottom of the sea, forming sedimentary rocks that later, probably due to tectonic processes, rose to form new continents. And all this was accompanied by falling meteorites whose remains we've found in the rocks. We don't know what the continents were like before the flood, if the surface was already split into plates or if it broke in the flood. But we believe that many of the plate movements we discussed earlier occurred at high speed. I'm actually going to show you them here in a quick animation. This is just an idea of what could have possibly happened, the movements of the plates. Until the current configuration. Well, we believe that many of these movements occurred at high speed during the year of the flood and in the immediate aftermath. So this created mountain ranges, caused tsunamis, and triggered volcanic eruptions around the world that filled the atmosphere with ash, which likely caused an ice age after the flood. We don't have time to explain this in detail, but I recommend that you watch the short presentation that Dr. Leonard Brand gave at the European Congress of Faith and Science that we had in the summer of 2019, and which is entitled, "What Happened During the Flood?" By the way, the speakers at this Congress were Christian specialists in matters of faith and science, from the fields of theology, biology, geology, and paleontology. Home Media España recorded, edited, and translated all the presentations, and they are now available in Spanish and in English for all those who are interested. I will leave you the links in the document of additional materials and resources. The level of these lectures is a bit more academic than this series, but they are still understandable and highly recommended for anyone who is interested in these topics. So in his lecture, Leonard repeatedly insists that we have never seen a global flood, and therefore we cannot know how accurate our models are. But we have a lot of data to suggest that it was a brutal event that completely changed the Earth. For example, when we see these types of geological structures in the mountains, we have to remember that these sedimentary rocks were formed in the lower parts of the Earth, usually at the bottom of the sea, and that the layers were deposited horizontally. So something huge had to happen in order to lift and tilt millions of tons of rock to the position where we find them today. In other places, like the Grand Canyon in Colorado, we see layers that coincide on both sides of the canyon, and therefore we have to assume that they were continuous layers before something very big and powerful cut them and created a hole between 6 and 30 kilometers in width with an average depth of 800 meters and which is almost 500 kilometers long. Conventional long-age models solve the problem by adding on a lot of time and believe that the canyon was slowly carved out by the Colorado River over millions of years. But we believe that this was a powerful drainage current that went through at the end of the flood that in a short time uprooted millions of tons of material and created the canyon. So who's right? We've already explained that the same data can be interpreted in different ways depending on the worldview of the researchers. But that doesn't mean that just anything goes, or that all the interpretations have the same weight or influence. To defend a model, we have to have strong data to support it. So I want to dedicate the last part of our talk today to tell you about some of the data that has been obtained from geological studies that are consistent with the biblical story of a universal flood. The first of these data is the presence of sedimentary layers that extend horizontally, covering thousands of square kilometers. In the previous photo of the Grand Canyon, you can see the layers of sedimentary rock that make up its walls. Well, it turns out that if we follow those layers up on both sides of the canyon, most of them continue for hundreds of kilometers, passing through various states of the United States. And as we move away from the Grand Canyon, other layers appear on top, forming cliffs at different heights, which is why this structure is called the Grand Staircase. If you look at this diagram and focus on the Grand Canyon, which is represented on the left side, that V that you can see there on the left, you can get an idea of the enormous dimensions of this structure. We said a little bit ago that sedimentary rocks have layers, and that these layers are formed when the eroded materials are transported by the wind or by water and deposited in a low area, where they are compacted and cemented until they become a rock. The question is this: what kind of atmospheric agent could carry and deposit enough material to cover an area of thousands of square kilometers that extends over several states? Currently, there's nothing like it. There is no river in the world, nor any ocean current capable of doing such a thing. This quote that I'm going to show you isn't taken from a creationist book, but from an article in a conventional geology magazine. And speaking of the layers of the Grand Staircase, the author states the following. Beds or the layers may persist over areas of many hundreds of thousands of square kilometers precisely because they are the record of truly oversized events. In many cases, it involves processes that have not been or cannot be observed in modern environments. There are the extreme events, with magnitudes so large and devastating that they have not and probably could not be observed scientifically. I don't know what it looks like to you, but to me, these kinds of expressions, truly oversized events, extreme events, magnitudes so large and devastating, well, they fit quite well with the biblical flood. So the first data in favor of the biblical flood is the enormous magnitude of the processes necessary to form some of the geological structures that we observe today. What happens with the time? Do we have data to suggest that the sedimentary layers that make up the Grand Canyon were deposited rapidly, as would have happened during the flood? Or does the data support the idea that they were deposited slowly over millions of years? Today, we're not going to talk about dating because we don't have time. We will try to briefly cover that topic in the last few sessions, but I suppose you've all heard of radiometric dating. It's a method used to measure the age of rocks based on measuring the radioactive elements found in some of them. When this dating method is applied to the layers of the Grand Canyon, The results are in the range of millions of years, hundreds of millions of years, which seems to favor the conventional theory of long ages. However, some of these results are very curious. In some places, two layers, one on top of the other, give very different ages that are separated by several million years. And sometimes the gap or the difference can reach 100 million years. That implies that after the first layer was deposited, millions of years passed before the next layer was deposited. Or that other layers were deposited on top of the first one that later eroded over millions of years, and then the upper layer that we see today was deposited. The funny thing is that the boundary between the two layers, supposedly millions of years apart, is a flat, horizontal surface with no signs of erosion. And that's really strange. If we look at the surface of the Earth today, we see that it has mountains, valleys, rivers, high and low areas. So how is it possible that the upper surface of a sedimentary layer remains flat and unchanged for millions of years, without anything being deposited on it or eroding it? Or there were processes of deposit and erosion that didn't leave any mark? The logical answer is that the two layers were deposited quickly, one right after the other, and that there is something wrong with the dating process. These supposed gaps of millions of years between the layers are not something that's occasional. They occur in many places in the Grand Canyon and elsewhere in the world, but when we look at the sequence of layers, there are no signs of erosion between them, which suggests that they were deposited one after the other rather quickly, and that the entire structure formed in a very short time. When you watch Leonard's talk, because I know you're going to watch it, you will hear him say something that he repeats multiple times, and I totally agree with it. It says, creationist researchers have an advantage over evolutionary researchers because we are obligated to know their position and arguments as well as ours. And that makes us have a broader vision. Also, the fact that we consider possibilities that they would never consider makes us see things that they don't see and gives us research ideas that they would never think of because they don't fit with the framework of their paradigm. Leonard has applied this to his own research many times and has been successful. And I will end by telling you about two of the studies that arose precisely from his belief in the biblical flood. The first is related to what we have just seen about the rate of deposition of layers in sedimentary rocks. If you have ever been to a beach at low tide, you will have seen a lot of animals like crabs and worms making holes in the wet sand. Well, this also happens at the bottom of lakes and seas. Bottom-dwelling animals are continually burrowing into the sediments, about 20 to 30 centimeters down, and even lower sometimes. Under normal conditions, the amount of sediment that reaches the sea through the rivers is only a few centimeters a year. So the activity of the animals would mix the materials that have just arrived with the previous ones and would prevent layers or different layers from being distinguished. There are some sedimentary rocks, like this one that you see here in the picture, in which those holes and burrows remain and are visible. This is what geologists call bioturbation. Leonard Brand decided to review the bioturbation literature and calculate what percentage of sedimentary rocks in the world showed signs of biological activity. If, as the conventional theory states, sedimentary rocks have been forming little by little over millions of years, there should be a large number of rocks with signs of bioturbation and very few rocks like this one with well-marked thin layers. Because the only way that these thin layers can be preserved is if the layers are quickly deposited one on top of the other, forming the entire sequence in a short amount of time and remaining sufficiently buried so that animals can't destroy it. Well, the results of Leonard's study agree with what was expected in the flood model. The vast majority of sedimentary rocks have well-marked layers indicating rapid deposition, and only a very small percentage have bioturbation marks. The second study I want to tell you about seems genius to me. Leonard Brand and Arthur Chadwick did it from their offices without having to go out to the field to investigate, by simply reviewing research from other authors and analyzing their results from a different point of view. For you to understand the study, I have to tell you what paleocurrents are. Earlier, we said that sedimentary rocks give us information about the environment in which they are formed. There's sometimes sedimentary rocks that form underwater have ripples or waves on their surface. And those ripples or waves were formed because the water above the sediment was in motion. In other words, there was a current. And experts in these things can analyze the shape of the ripple waves and know the direction of the current, which, being an ancient current, is called paleocurrent. When a geologist publishes their studies on the rocks of a certain area where they have also found paleocurrent marks, the normal thing is that when describing the structure, they include the information of the direction of the current in the article. So Leonard and Arthur went through all the published articles that spoke of paleocurrent markings and rocks in the United States. They compiled all the information and put it into a unique database. And why did they do that? For secular geologists, water currents etched into rocks at different locations in the United States were independent phenomena. One would be a river, another would be a current at the bottom of a lake. But it made no sense to compare them with each other because for them, they had nothing to do with each other. But Leonard and Arthur, who believe in the biblical flood, thought that perhaps many of these currents were part of the same event, the flood, and that perhaps if they compared them, they would find a pattern. They could have been wrong. A researcher taking their ideas from the Bible does not guarantee that they are true. They must be verified empirically. That's what Leonard and Arthur did, and in this case, they were absolutely right. By putting all of the directions of the currents marked on the rocks into the same database, a general pattern appeared that covered the entire United States. That would change as they went higher on the geological column. In the deeper sedimentary rocks, which would correspond to the early stages of the flood, the currents showed the water entering the continent and forming a kind of whirlpool in the center. And higher up, which would be later in the flood, the water runs from the mountain ranges as they are forming. And finally, in the highest layers of the geological column, which according to our models would have been deposited after the flood, there was no longer a general pattern, but rather each current was independent of the others. I've already said that for me this study was genius. And it's not only me who thinks this. It is so well done and the results are so indisputable that it was accepted for publication in a section of the Nature Journal. But curiously, they allowed them to publish the database, but not the maps, which are a geographical representation of the same data. I'll let you think for yourselves why. As you have seen, you don't need to use old-fashioned arguments, such as marine fossils in the mountains, to support the flood. There is a lot of evidence from current studies that agree with biblical history. But I also want to remind you that we're not trying to prove the Bible. The Bible has its own authority that is not contingent on what science says in each historical moment. But the truth is that studying nature and finding evidence that matches what the Bible says, it feels great. And that's not all. There are other evidence from paleontology, which we will see next week. Fossils are an exciting but very broad field, so the same thing will happen again next week. I will talk about a lot of things in a very short amount of time. So I'm going to give you homework, which is completely voluntary, in case you want to come prepared. 2 lectures from the European Congress of Faith and Science regarding fossils. One from Dr. Ronnie Nalin, titled Inspector Gadget Goes to the Morgue. And the other from Dr. Raúl Esperante, titled Would You Like to Become a Fossil? I will share the links through the chat as well as in the Google Docs list. They are available in both English and in Spanish. And that's it for today's topic. We'll see you next week, again with the topic, What do fossils tell us?